When an agent confidently invents an answer, engineers will often start by debugging the model's underlying reasoning capabilities. Data published by Anthropic in late 2024 suggests the problem starts much earlier in the pipeline. Adding contextual embeddings reduces retrieval failures by 35%. Contextual BM25 moves that to 49%, and re-ranking brings it to 67%. Prompt caching keeps this at roughly $1.02 per million tokens, making it economically viable. The mechanical reality is that the model is often performing exactly as instructed. It simply never received the semantic chunk containing the truth. In this architecture, we treat reasoning failures as a primary indicator of information loss during retrieval. This is Bearded AI Guy. We are breaking down the architecture decisions that determine whether an agent is production-ready or a liability. It is day 2 of our 7-day RAG helpdesk agent build. Today, we build the Knowledge Store, a sub-50 millisecond system designed around a 6-stage pipeline. We will specifically address the configuration errors that lead to cross-tenant data leaks in multi-user environments. The decisions made at this stage establish the security and accuracy limits of the agent for the rest of the build. To build this, we have to distinguish between a knowledge base and a knowledge store. A knowledge base is the collection of documents, the PDFs, Zendesk articles, and Slack archives that humans browse to find answers. A knowledge store, on the other hand, is the highly structured, queryable, chunked database that an AI agent retrieves from in under 30 milliseconds. In this store, the unit of data is the semantic chunk, paired with metadata filters that define who can see it. This translation from human-readable documents to agent-queryable data requires a sequence of transformations. We define these 6 stages as parsing, chunking, embedding, indexing, metadata enrichment, and the refresh policy. Each of these transitions is a point where data structure determines whether the agent can actually find the relevant information later. Consider a pricing table inside a PDF. Naive parsers often flatten these tables into a stream of comma-separated numbers. By destroying the row and column structure, the parser ensures the agent will quote the wrong price, regardless of its reasoning capability. These represent the 3 tooling tiers available for the parsing stage. Native and layout-aware open-source parsers work for clean text, but they often fail silently when they encounter complex tabular data. Agentic parsing services like Reducto use a multi-pass approach, where an OCR layer specifically identifies and preserves table relationships in real time. Reducto maintains a 90.2% cost of running agentic parsing is consistently lower than the engineering hours required to fix a pipeline that produces garbled data. Anthropic's contextual retrieval pattern solves a specific chunking problem. It prepends a 1-sentence document summary directly to each text chunk before it is indexed. This provides the necessary context for the retrieval system to see that 67% reduction in failure rates.
The system uses a specific prompt to situate the chunk within the document, ensuring the retrieval engine understands exactly where the information originated. This contextual chunk is then routed to both a vector store for semantic matching and a lexical BM25 store for precise keyword search. This fixed-size contextual method is more computationally efficient than dynamic semantic chunking. NAACL 2025 research confirms that fixed 256 to 512 token chunks match or exceed the performance of more complex semantic slicing. Because of prompt caching, the model overhead for generating these summaries is no longer a significant cost barrier. Using contextual retrieval over hierarchical chunks ensures the agent doesn't lose the surrounding document context during the search. Builders today have to choose between dozens of model and index combinations. These 2026 defaults represent the specific winners in retrieval quality and operational latency. Voyage 3 Large currently leads in retrieval benchmarks. For high-volume projects where cost is the priority, Gemini Text Embedding 004 provides a performant, low-cost alternative. If your stack is already on Postgres, PG Vector is the logical default, maintaining 8 to 25 millisecond P95 latency. For corpora exceeding 10 million vectors, TurboPuffer offers significant cost-to-performance gains, while Pinecone remains the choice for managed simplicity. These specific pairings provide a stable performance baseline, allowing you to focus on the agent's logic rather than infrastructure bloat. In production, the system must distinguish between finding the most relevant text and finding the most relevant text the specific user is permitted to see. We manage this through a metadata schema that includes fields for source, access level, tenant ID, and content freshness. B2B multi-tenancy typically follows one of these three patterns: silo, pool, or bridge. The bridge pattern is the current SaaS standard. It allows core product documentation to be shared across a pool while keeping sensitive client data in isolated silos. A failure here leads to tenant isolation drift, a bug that can leak one customer's private data to another. To prevent this, metadata filtering for the tenant ID and access level must happen before the vector search executes. This represents the finalized 6-stage pipeline for a high-accuracy knowledge store. We use these specific tools, Reducto for tables, Voyage for embeddings, and pgvector for the index, because they address the specific failure modes of help desk retrieval. The metadata schema serves as the enforcement layer for legal and technical boundaries within the search. This architecture provides the grounding required for the tool integration and routing loops we will build later this week. While humans browse a knowledge base, an agent depends on a knowledge store that is actively maintained across all 6 stages. If you are seeing specific friction points in your parsing or chunking, let us know in the comments. On day 3, we move to tools, treating this knowledge store as the data interface the agent uses to resolve tickets. If the agent invents an answer, debug the retrieval. The model didn't lie, it just lacked the chunk.